Okay, so welcome back, and now we're going to talk about a couple of other examples and how to tell a limit looking at a graph of a function now. So if we look at these two graphs, and we'll start with this one here. By looking at the graph, what do? We approach the value, so it says here, look at the graph, what's the limit as x approaches -1 of g of x? And so here's the graph of g of x. Well, if we inspect by visually inspecting the graph, what do? We look at where it's approaching from the left or the right, and where is it approaching from the left. And so we can see that this is approaching as we get closer and closer to -1, it's getting closer and closer to what? It's getting closer to 3. And so based on the graph, we would say that the limit of the graph is 3. Okay, that's it. Now, the conclusion is notice that in this case here, at x equals 3, what is the value of the function? So in other words, what is g of -1? Well, according to the graph, the value of the function at x equals -1 is 4. So notice that in this case here, the value of the function evaluated at x equals -1 is not the same as the limit of the function as x approaches -1. So that means the limit and the value of the function at that limit, or at that value of x, doesn't necessarily have to be the same. Okay? In fact, the value of the function doesn't necessarily have to exist in order for the limit to exist, and that's what we're going to show you here. Because here, at this function here, there's a hole in the graph at x equals 2. But does that mean the limit doesn't exist? No. Because as we inspect visually, approaching this point, x equals 2, from the left and from the right, we see that it does approach the same value. What value does it approach? It approaches -1. So we would say the limit of this function as x approaches 2 is -1, even though the value of the function g of 2 does not exist. Okay? And that's it. Have a great day.